Hi, in this video, we're going to talk about the ICMPv6 router advertisement, router solicitation, and what they have to do with router and prefix discovery. Okay, so we have seen the router solicitation and router advertisement message many times when we talked about dynamic address allocation, DHCPv6, Slack, and all that good stuff. So some of this will be old hat, and I won't cover a lot of that stuff again. If you want more information on those two messages, you can look at those videos or read that portion of the book. But as we know in IPv4, life is quite simple, or limited, maybe I should say, that the only way addressing information can be received dynamically is through a stateful DHCPv4 server. In IPv6, the router can, when configured with the IPv6 unicast routing command, becomes an IPv6 router, which means one of the things it will do is send out router advertisement messages. Yep. All right, and that's going to inform end devices how to obtain their addressing information dynamically, either via Slack with stateless DHCPv6 or stateful DHCPv6. So a stateless or stateful DHCPv6 server may or may not even be needed. Okay, we had taken a look in previous videos, previous chapters, about the three flags that's associated with the router advertisement and the type of addressing that it suggests, either Slack with stateless DHCPv6 or stateful DHCPv6. So we had looked at the A flag, the O flag, and the M flag. Okay, and if you want more information on those flags, please see my videos or that portion of the book that talks about dynamic address allocation, Slack, stateless DHCPv6, and stateful DHCPv6. So a router solicitation message. This is sent when an end device wants to receive a router advertisement message. Okay, it's sent to all IPv6 routers, sent from the link local address of the device, but it can also be sent from the from basically its address that when it doesn't care, when it wants to either remain anonymous or it doesn't matter what the source IPv6 address is. So it can also be sent from what's known as the unspecified address, which is basically a all zeros address. Anyway. This is the router solicitation message. The router advertisement message is sent every 200 seconds by default on a Cisco router or in response to a router solicitation message. Okay, it's sent to all IPv6 devices, even when a router solicitation message is why it's sending the router advertisement. It also is sent from its link local address. By the way, it can be sent to a unicast address this can be sent instead of all IPv6 devices multicast, could be sent to the address that requested the router advertisement. This is something that you can configure in the router advertisement for this interface. Why would you do this? If this is a wireless device, or if the link is a wireless link, let's put it that way, then you may want to send router advertisements specifically to a device so it's not having to wake up the other wireless devices for power conservation. Okay. All right, so let's analyze a router solicitation message. All right, so in the router solicitation message, here's our ICMP. Remember, type field, code field, checksum, and then kind of the data here. The type is a 133 code 0. Remember those type options we talked about? Well, a valid option in a router solicitation message is it will also include the type 1, the link layer address of the MAC address of whoever is sending this router solicitation message. Okay, let's take a look. So first of all, the Ethernet destination MAC address is actually a multicast MAC address that maps to all IPv6 routers. Remember, this is always more efficient than a broadcast because only devices that need this, that are part of this multicast group, only their NICs need to process this. The other ones can filter it. Okay. So we can see that it comes from the source, in this case, link local address of PC1 that's requesting the router advertisement. This is a router solicitation message. And it goes to all IPv6 devices. This is the multicast address that actually maps to that MAC address. So we see 3333, which is the first part of the MAC address that specifies this is a IPv6 multicast, that the information that's what it's carrying, and then these bits here map to these bits here. Okay. All right. So that's how that works. Remember, so we have just kind of so remember these are 4 each. So we have 8 and 8, so we have 16 bits here, right? So this is a 48-bit address, right? So we have 32 bits here that map to these 32 bits here. So it doesn't map to the entire interface ID, not all 64 bits here, but enough of it to make it know that this is for a device that is basically an IPv6 router. All right. Continuing looking at this, the next header field is hex 3A decimal 58 that says it's an ICMPv6 message. Okay. Type 133 means this is a router solicitation message. The ICMPv6 option is a type 1 option, okay, which means that it's the router solicitation message includes the link layer address of the source. Why would it do that? That's because if this router wants to send a router advertisement message to specifically to this address, then it knows the MAC address. It doesn't have to do any address resolution. It doesn't have to ask the device, hey, what's your, I know your IPv6 address, but what's your MAC address? It's included. Okay, if we look at a router advertisement, okay, we can see the valid options here contains also that same source link layer address, MTU, and prefix information. So let's take a look. So first of all, router becomes an IPv6 router with this command here, and it joins the all IPv6 multicast group. Yeah, so we see that it is part of the all IPv6 multicast group. Just the default IPv6 router advertisement is they're sent every 200 seconds by default, and only the A flag is set to 1. The M and O flags are set to 0. Okay, if we analyze this looking at Wireshark, okay, we can see that the Ethernet multicast MAC address maps to the all IPv6 address. We'll see that here in a moment. Let me go to it right now. There it is. So the last 32 bits of the destination IPv6 address maps to the last 32 bits of the MAC address. Okay, so only IPv6 enabled devices, which is actually all devices, need to see this router advertisement. Okay, we see that the next header field is 03A, meaning it's an ICMPv6 message in the payload. It is sourced from the link local address of the router, which end devices will use this as their default gateway. And again, this router advertisement message by default is sent to the all IPv6 devices multicast. But as we mentioned previously, this could be the IPv6 address along with the link local address of the end device that sent the router solicitation message. You can actually configure that option on the router's interface to do that. Okay. So looking at the ICMPv6 message, we see that it is a router advertisement 134. Here's the current, this is the hop limit, the recommended hop limit value. So it's telling hosts to set their hop limit in their IPv6 headers recommended to 64. We can see the M and O flags are set to 0 by default. Okay. Looking at some other information here, we see some various options. So the source link layer address option 1, so this actually includes the link layer address of the router. So the host has this, doesn't have to send a neighbor discovery message, the neighbor solicitation message to receive the MAC address of the router. The MTU of the link, which is 1500 right here, and also prefix information, which is here. So we have the options of source link layer address, MTU, and prefix. There's the prefix. So this is the prefix for this network. We can see the A flag is set to 1, and the on link flag is set to 1, meaning this prefix should be considered on link. Any devices with this prefix can be reached directly without going through the router. Pretty cool stuff, huh? Okay, so that's the router and prefix discovery, really the router advertisement, router solicitation messages. We'll look at the neighbor advertisement message and neighbor solicitation messages in the next video.